Assalamu alaikum everyone, it's Mr. Kamal Taizi speaking. Welcome on my channel. Today inshallah we'll focus on the motion in one dimension. As you know, we have a different kinds of motion, 1 dimension, 2 dimension or 3-dimensional motions. And also we have rotational motion and other kinds of motion. But today inshallah we'll focus on the motion in 1 dimension, part 1. Let's start. Okay. First of all, I want to ask you something. If you look over for all of things in our universe, you can see that everything in motion. Okay, everything, even your chromosomes in your cell also in motion. Okay, everything in our life is moving every time. Okay, but now I'm sit down here in this chair and I'm in rest. Now, I'm in motion or not? Now, let's see today what about that. Okay, let's talk about the motion in 1 dimension. Of course, guys, the motion in 1 dimension, it will be the simplest form of motion, okay? It will be the simplest form of motion. If we have someone walking like that, okay, in a straight line, like this guy, okay, he is walking, okay, he has a long leg anyways. Now he is in motion, in 1-dimensional motion, okay? And also this train is in 1-dimensional motion. It is that train move forward or backward. Both of them are in 1-dimensional motion, and that is the simplest form of motion. Okay, what about this guy? Now, this guy is walking in 1-dimensional motion, of course, okay? Now, okay, what about the same guy, but he's standing up out here and he is in rest. Now, he is in rest or in motion? What do you think? Yeah, for me and for you and for the dog, he is in rest. He don't make any motion, okay? But if we take another look outside of our earth and suppose that we can see the same guy, and we have another one can see this guy from outside, now he can see him in motion, and very fast motion, because the earth is in motion. Okay, now the earth is moving around its equator in 1700 kilometers per hour, because that's this guy in motion. What about the earth around the sun, and also the earth around the sun in motion? Everything in our earth in motion. Now when you are in rest like this guy outside, he is in rest for me and for you, because we are seeing him like that. But if we look over out of the earth, now the earth in motion, because this guy is in motion. Okay, let's take another example. Suppose that we have a train and we have guy inside the train, okay, and he is standing up, okay, and we have another one outside. He is looking for this guy, and the train is in motion, is moving. Okay, now because of the train is moving, this guy, he will see the other one on the train is in motion, but in fact he is in rest, not in motion. Now, but if he is walking more, now he can see the other guy, this guy outside. He can see the other guy. He will be faster, okay, because he has 2 speeds, the train speed and the guy speed or the man speed. Okay, now as you see here, we should know who will determine or account the velocity or the motion. Okay, that's called what? That's called frame of reference. Okay, what's the frame of reference? The frame of reference, as you see here, is a system. Okay, is a system for specifying the precise location of the object in space and the time. Okay, the system to determine or to specifying the location and the time. Okay, where the location it will be and which time we will calculate or account. Okay, where the location and how much time we have. This is the frame of reference. Is very important to understand the motion. Okay, let's enter to the first quantity do we have in the motion is called the displacement. Okay, when we have man and this man is walking and walk from this place, okay, to another place, okay. In the first second he was here, after 10 seconds he go for 10 meters, okay. Now this is the location. He was here and now he is there, okay. Now this the position is changed, okay. Now the changing in the position for the object is called displacement. The changing in the position for object, it's called the displacement, okay. Now by easy way, very easy equation to understand the displacement more. Now displacement is change in position. As you see here, this symbol called delta, okay. Yeah, this symbol called what? Called delta. You can see that here. What the meaning of delta? Delta means a change in position, okay. Change in position. Any delta do you have, it means minus. It means change in position, okay. Now to account or to calculate the displacement, we need to find the final position minus initial position. What is the final and what is initial? For this guy, the start point is here and the end point is there. Now the start point is called initial position, final point is called final position, okay. Now we have initial position and final position. Now to calculate the changing position or to calculate the displacement, final position minus initial position, okay. So very important to understand the final position, it will be the first one every time, okay. When we calculate the displacement, you should to start with the final position minus initial position, okay. 10 minus 1, it equals 9. It equals 9 meter, positive of course, okay. 9 meter, that is the displacement for this guy to change position from here to there. That is the simple way to understand the displacement, okay. Let's talk more about the displacement from this Jaco. Now as you see here, another example for the Jaco, he start from here 20 and end there 80, okay. Now this is the final position and that is the initial position. 80 minus 20, it equals 60 meter, okay. It will equals 60 meters, okay. Now what about the same Jaco, but now he will moves up, okay. Now he will moves up. What do you think? It will be also one-dimensional motion. What do you think? Yeah, it will be the same one-dimensional motion, okay. But the difference here, it will be in y-axis, not in x-axis. It was in x-axis here, but now now change position to goes up, okay. Nothing more, nothing much, but it will be the same. It will be one-dimensional motion, and here we will make the same thing, but we just change the symbol. Why? Because this in y, okay, delta y equal yf final position minus yi initial position, and we will do the same thing, okay. Let's talk more about the displacement. The displacement sometimes it will be positive or negative. Yeah, it means we have a vector, okay. We have a vector. We have vector for the displacement. As you see here, for example, yeah, if we take a look for this one, here we have 80, okay, minus 10. Final minus initial equals positive 70 centimeter, positive. That it means the direction here it will be positive. What about that? Here also it will be 12 minus 3, okay. It will be positive also, positive 9, like that. The same thing here, but here we have minus 10, as you see here. Now in this one, as you see here, we have 6. This is the final, and the initial it will be minus 10. 6, okay, 6 minus 10, it equals also positive 16, okay. Now what about that here? Now this ball will change the direction. Here it will move to the right or to the east. Here it will move to the west, okay. Now when the ball moves to west, it will be negative displacement. Where the final here? Where the final here? The final here start from here, and the initial here. We should start from the final. 20 minus 80 equals minus 60 centimeter. Okay, The same thing here, okay? Yeah, we'll start from the final, search for the final, and start now 0 here, start from 0, okay? 0 minus 15 equals minus 15. Here, final, start from the final, like this here, we start from the final, okay? The final minus the initial. Now, final, here I can see that, well, I think it will be for this one here, as you see here. Now, this is minus 20. Yeah, minus 20. And this one is minus 8, because this, yeah, and minus 10. Okay? It equals minus 10 centimeters. Okay, now as you see here, the displacement sometimes it will be positive and some another it will be negative. Why I explain negative and positive for you? Because after that, inshallah, we will speak about something else called distance. Okay, and the distance difference between the displacement. Okay, because that here he should understand the displacement have a vector. Okay, sometimes it will be positive, some another it will be negative, and remember that because we will speak about distance, and I will ask you about that if you remember or not. Okay. Okay, as I told you, we will talk about the difference between the displacement and the distance. Okay, in this part, I will explain for you what the difference between displacement and the distance. I think you can realize that because I spoke about the displacement before, right? And I told you we have a direction. What about distance? Let's see next session, inshallah. Goodbye.